Now we will start with the questions that have 5 points for each. In question number 21, some glasses are stacked on top of each other. A stack of 8 glasses is 42 centimeter high and a stack of 2 glasses is 18 centimeter high. How high is a stack of 6 glasses? Okay, at first here we have this one is 18 centimeter. So, and until here, the entire height here we have as 42. Now here we have 8 glasses and here we have 2 glasses. So here we have 8 and here we have 2. So now if we subtract 18 from 42, we will obtain 24. And this 24 is the height of this part here, 24. And here we have 6 classes, so each one of them will be 4. If we divide 24 by 6, we will have 4 for each one of them here. So also this one would be 4, and the rest here, if this one is 4, so and here we have 18, so this one will be 14, the first one, because the first one will be the longest one. Now they are asking us for 6 glasses, so we will count here 1, 2, 3, 4, 5, and 6. So it is 42 minus these two cups here. So 42 minus 8 will give us 34, and D is the correct answer. In question number 22, in the picture above, each animal represents a positive integer and different animals represent different integers. The sum of the two integers in each column is written below that column. What is the largest possible sum of the 4 integers in the first row? So here I should make the integers in the first row bigger and make the integers in the second row smaller as possible. So let's start with this column here. We have the sum of these two integers is 3, so I will put here 2 and here I will put 1. Now here we have 7, so I can put here 4 and here 3 because I cannot repeat the same integer. And now here we have 11, so I can write 6 and 5 here. And here we have 15, so I can write 8 and 7. Now if we sum the integers in the first row, we will obtain 20, and C is the correct answer. In question number 23, to unlock this lock, you get the following 4 hints. So if you look here, all of these digits are incorrect. So 7 and 3 and 8 are incorrect. So if we look here now, one of these digits is correct and it's the right place. So here we will remove 8 because it's not correct. So one of these two digits, 6 or 2, is correct and in its correct place. So if you look here, one of these digits is correct, but in the wrong place. So 6 cannot be correct because now here 6 and 6 here in the same place. So if this one is correct, so this one should be correct. So I will remove also 6. Now we have 2 is correct and in its correct place. So I will have here 2. Now let's look here. 2 of these digits are correct but in the wrong place. So I have 2 is already taken, so either 6 or 0, and we know that 6 is not correct, so 0 is left, and now 0 but in the wrong place, so it should be either here or here, but this place is already taken, so I will put 0 here. Now we just have to know now the last digit. So if we look here again, one of these digits is correct but in the wrong place. So 1 cannot be the correct because here if we assume that 1 is the correct digit, we should place it here or here, and these two places are already taken, so 4 is the correct number and 4 should be placed in the middle. Now 0, 4, 2 is the correct answer and D is the correct answer. In question number 24, Layan has the shape shown above. Which of the following shapes is the same as Layan's? Okay, here as we can notice, all of these columns are connected from the middle here and here. So we don't have, like, for example, two columns are connected from the sides. So if you look here, we can remove this one because this one is not connected from the middle, so B is not correct. And also we can remove D, because also here in D we have two parallel columns, and we don't have in our shape two parallel columns, so this one is not correct. And also this one, we can remove this one because these two are connected from the side, so E is not correct. In A also we have here these two places are connected from the side, so also this one is not correct. So what is left is C, and C is the correct answer. In question number 25, Amir chooses four of the numbers 2, 3, 4, 5, and 6 and writes one in each box so that the calculation is correct. How many of the five numbers could Amir write in the shaded box? Okay, now let's call each one of them as with a number, with a letter A, B, C, and D. Okay, now we have A plus B minus C is equal to D. So if we move this one to this side, we will have A plus B equal to C plus D. Now we will search for four numbers so that each two numbers is equal to the sum of the second two numbers. So for example, here we have 6 and 2, which is 8, equal to 8, the sum of them, and 3 and 5. So I can write 6 plus 2 is equal to 3 plus 5, or 6 plus 2 is equal to 5 plus 3. And I can write 5 plus 3 is equal to 6 plus 2, or 5 plus 3 is equal to 2 plus 6. So for D, I have four possible numbers to take, and D is the correct answer. In question number 26, the numbers 3, 4, 5, 6, and 7 are to be placed in the five circles below so that the number inside each triangle is the product of the three numbers on its vertices. What is the sum of the three numbers on the vertices of the colored triangle? Okay, here to solve this question, let's look at these two numbers here. So they are multiples of 5, because we know that all the multiples of 5 start with 0 or 5. So we should write 5 in a circle that is common between them. So we cannot write 5 here because here we have 84 and 168. So it's not correct to write 5 here. So we will write 5 here. Now for this circle in the middle, we cannot write 4 or 6 because here we have 105, and 105 is an odd number, so we cannot use 6 or 4. So I need to use 3 or 7. If I place 3 here, I will obtain 15 here as a product of 3 and 5. So I need a very big number here to obtain 210. So I will not put 3 here, I will use 7 instead. So now if we multiply 5 and 7, we will obtain 35, and so we need here 3 to obtain 105. And now let's continue and find the other numbers. So here we have 3 and 7. If we multiply them, we will obtain 21, so we need here 4. So, and now if we compare, we need here 6 because this is the last number here. So what is asking for is the sum of the three numbers on the vertices of the color triangle. So we need to sum 7 and 4 and 6. So if we sum them, we will obtain 4 plus 6 is 10 plus 7 is 17, and D is the correct answer. In question number 27, which of the following nets cannot be folded into the solid box? This one. So here we have these two lines are vertical on these two lines. So let's check. And here we have a plus sign. So here, these two can be the front side here, and this one can be the side on the right. And here we will have these two side on top. So this one can be the answer, can be correct. So we will not select A. Now let's look at B. If we consider this one as the side face, so we will have these two, but these two are vertical, not horizontal, so this one cannot be. Now, if we assume that this one is the side face, and these two are horizontal, So we will have these two on top of them, and they are also horizontal, not vertical. So this one cannot be correct. So no need to continue with the other answers because this one is not correct and B should be selected. In question number 28, the four villages A, B, C, and D lie along a road in that order. The distance between neighboring villages is 10 kilometers. There are 10 students who live in village A, 20 students who live in the village B, and 30 students who live in a village C, and 40 students who live in village D. The villagers want to build a school so that the total distance traveled by the students when going to school is as small as possible. Where should they build the school? Okay, so we have these villages here, A, B, C, and D, and between each two villages we have a fixed distance, which is 10 kilometer. So now we have to decide at which village we should build the school. So at first, if we assumed that we will build the village at A, so if you write here A and look, so now if we look at A, so the students at A will not cross any distance, so we will have 0 for A. Now for B, the students we have 20 students and they will cross 10 kilometers, so we will have 200 kilometers. And for the students in the village C, we have 30 and they will cross 20 kilometers, so we will have 600 kilometers. And now for D here, we have 40 students and they will cross 30 kilometers, so we will have 1,200 kilometers. So in total, we will have 2,000 kilometers. Now, if we assume that the school will be built at B, in the village B, so we have A is equal to 10 students, they will cross 10 kilometers, so 100. And we have the students in the village B will not cross any distance, so 0. In C, we will have 30 students will cross 10 kilometers, so 300. And in D, we will have 40 students will cross 20 kilometers, so 800. Now here we will have 1,200 kilometer. So if we build, until now, if we build the school at B, it will be better than building it at A, so we can exclude this answer. Now let's check if we build the school at C. So if you build it at C, we will have A as 200 and B as also 200 because we have 20 students and we will multiply it by 10 kilometers, so we will obtain 200s. And C, we will obtain here 0 because the school is built in C, the village C. And for D, we have 40 students, they will cross 10 kilometers, so we will have here 400. So in total here we have 800. Until now, this is the smallest number. Now, if you assume that it will be at build at D, so we have A as 300 and B is 400 and C is 300 and D is 0. So here we will obtain 1,000 kilometer. Now, here in C, we have in the middle between B and C. So this is the last situation here. We have here in this point between B and C. So for A, it will be 150. For B, it will be 100. And for C, it will be also 150. For D, it will be 600. So if we sum all of them, we will obtain also here 1,000. So this one is not accepted. So the least one, when we build the school at C and D is the correct answer. In question number 29, the three pictures show a structure made from cubes as seen from the top, from the front, and from the right. What is the maximum number of cubes that could have been used to build the structure? As we can see here from the right, this face, we have 4 as a width and 3 cubes as the height. Also here from the front we have 4 and we have 3 as height and 4 as the width. And from the top we have alongside here we have 4 cubes and here we have 3. So we will draw a 4 by 4 by 3 rectangular prism. Okay, after drawing the shape, so we will now draw the front and the top and the right faces. So we have here the front face, which is this one here. And now we will draw the up face, top face. So we have this here and like this, and like this. So this is the top face. Now let's draw the right face. So we have this here, like that. Okay, now let's see. So here we will not have any triangles, cubes, and here, and here, and here, and here, and here. So these places will be empty. Now let's count the number of existing cubes. So here we will have just one cube here, because here if you look from the front we just have one cube is appearing, so we cannot have more than one here. Now here we will have two, because here if we notice here we have just two from this side, so we cannot have more than two. Although here we have three, but we cannot put three here because in this side here we have two, and here similarly also two, and here we will have just one, because here also we just have one from the right side, and here we will have three, because here we have three and here we have three, and also here we will have three again, because here three and here is three, and similarly for this one is three and this one is three, and this one here is one, because here we just have one. Also here we have three, but here we have one, so we will have one here. Now the number of cubes will be the sum of these numbers here. So if we sum all of these numbers, we will obtain 19, and B is the correct answer. Okay, now in the question 30, the last question, 30 people are sitting around a circular table. Some of them are wearing a hat. Those who do wear a hat always tell the truth, while those who do not wear a hat can either lie or tell the truth. Each person says at least one of my two neighbors is not wearing a hat. What is the largest number of people who could be wearing a hat? Let's assume that this one is our circular table, and we will have at first a person who is wearing a hat. Now this person will say at least one of his neighbor is not wearing a hat, so we will, and this one is always telling the truth because it's wearing a hat, so we will put here a person who is not wearing a hat. Okay, now we will have another. If we have another person here is wearing a hat, now this one is telling the truth also, and is saying that one of his neighbors, at least one of them, is not wearing a hat, so also this one is telling the truth. Now this one may tell the truth or not, so it's not important. So I can put here another person who is wearing a hat, so also for this one here I should put another person who is not wearing a hat. So all of them now, all the people that are wearing the hats are telling the truth. Now I can put another one who is wearing a hat, and another one is wearing a hat, then one doesn't wearing a hat. So here between each three we have two wearing a hat and one is not wearing a hat. So for each three we have two wearing a hat, so for each 30 we will have 20, and D is the correct answer. And by solving this question we have reached the end of this exam. See you in the next videos.